Ah, yes, polynomials. Welcome to CS202 Fall 2022 Assignment 6. We have SpongeBob there. He's feeling happy about the assignments. I think this is going to be just fine. So for this assignment, we're going to implement a polynomial class. So let's go ahead and first consider the following polynomial right here. So 5x to the fourth minus 3x squared plus 10x plus 20. So we're going to write this class polynomial. It's going to allow us to overload a set of operators to multiply, add, subtract two polynomials or a polynomial with an integer and so forth. So the best way to really visualize this is this polynomial given to us right here. We can easily sort of I guess visualize it in the following array. So this polynomial has a degree of 4. So degree of 4 means the actual array is going to have 5 elements because we start from degree 0 up to 1, 2, 3, and 4. So 4 is a degree, but we have a size 5 array. So be very mindful. That's going to be really the, you're going to have to constantly be careful about that. So in this example, really a polynomial is a set of terms that have coefficients attached to them. So in this case here, 20, well, 20 can be thought of as 20 times x to the power 0. So index 0 of this array has the value 20. So 20 is going to be the coefficient attached to the x to the 0 term. And then 10 is going to be attached to the x to the power 1 term. So for index 1, we have a value 10, which implies 10 is in that 1's place. And then negative 3 is it's going to be applied to x squared, so the index 2 implies that negative 3 is a coefficient for x to the power 2 term. Then there is no x to the power 3 term in this expression, so we have a 0 for that. So 0 times x to the power 3 doesn't appear in this polynomial. Then, of course, 5 is a coefficient that's going to appear in front of x to the power 4 terms. So if you look at all of these indices, that's going to be the exponent of that term, and then the number stored in each element in this array will be the coefficient. So hopefully this is actually a very simple way of being able to visualize a polynomial in array form. So you're going to store polynomials like this within our class polynomial. Now if you look at this class right here, it does look rather intimidating, but for the most part, these functions are kind of, I would think the only hard function to write might be really this first multiplication function. Multiply a polynomial with a polynomial. Now I'm going to use OneNote and sort of draw out some examples to give you some help as to how you can write this program. And in fact, you can reuse some of the functions in this program elsewhere to sort of condense your code, but of course that's not a requirement, but I'll give a little bit of a hint as to how you want to approach that. So for right now, in our private members, we have poly_expr. It's going to be that array. So it's a pointer that's going to point to an array which will hold your polynomial, and degree is going to be the degree of the polynomial. So remember, if a degree is 5, then this poly expression will have the length of 5 plus 1. So it's going to be always set to degree plus 1 in your constructor. So always be careful with that because you can easily make a mistake and go beyond your array bounds, or make some mistake and have a seg fault, or who knows what else happens with pointers. Pointers are really not a lot of fun in C++. Or we embrace them, but they're also really tough to work with, especially if you're new to pointers. So I have the entire the explanation for everything in my class. Of course, you can read through this on your own, and I don't want to really spend the video, reading this to you because I'm pretty sure you can read this. So I'm going to actually now use OneNote and kind of give you a nice pictorial representation as to how we can visualize all these functions in this class. So let's get to it. Okay, so I'm not going to spend too much time in going into detail into the constructors because those are relatively straightforward. I'm going to just try to focus on the more complicated stuff here in this video. So let's first start with this operator star, which multiplies two polynomials and returns the product polynomial. So consider the following example like this. Let's say in main, I create the following polynomials. Actually, I'm going to create one more polynomial as well. Let's call it result. Okay, so we have P1 and P2, and we pass in this array into P1 and pass in array B into P2, and also you pass in the degree. So if you have size, you have 4 terms, the degree of this polynomial will be 3. We pass in 3 terms, the degree is going to be 2. So we can visualize P1 and P2 as the following polynomials that we have described right here. So we can this is going to be how we can visualize the 2 polynomials. Because remember, we see that the leftmost element, 3, is an index 0, so 3 will be in a 0th place, 2 is going to be x to the power 1, 5 is x to the power 2, and negative 2 is involved with x to the power 3. So that's how we can look at this. So in main, we would go ahead and maybe do the following. Result equals P1 times P2. So when we have this situation, what's going to happen is, remember how operator overloading works? We represent it like this, but we can actually visualize this code in the following way. We can say actually it's P1 dot operator P2. So we're calling P1's operator star function. Oops, I didn't put a star there. Operator star function, and we're passing P2 as an argument. So it's written like this, but we can visualize it like this. So what's happening is the following. So right now in this function body, we have this arrow poly expr, which is really going to just be P1. It's going to be P1's expr. And then we have RHS, which is short for right-hand side, RHS dot poly expr. That's going to be this object's polynomial. So we have to go ahead and use those exprs to be able to work this out. And of course, the product polynomial is going to get returned and assigned to result. Now, actually, I made one mistake here. It's supposed to be an actual const function at the end. So let me just go ahead and sort of put that there in this. That's one mistake I made. So it's supposed to be a const. And the reason why is this function is not supposed to modify this object. So we want to make sure we don't modify this object. And since this parameter RHS is a const reference parameter, it also is not going to be able to modify it. And we don't really want to modify them. Well, you know, the reason why we don't want to modify them is because, like right here, for example, if I say P1 times P2. So if you think about this expression just algebraically or arithmetically, we're going to essentially take P1 times P2 and it returns a result which will get assigned to this result polynomial. But if you notice, P1 and P2 should not be updated at all in this expression. So we don't want P1 or P2 to be updatable because they shouldn't. We just simply return a new object, and then if it gets assigned to a result, then P1 and P2 don't change. So, I mean, think of it like this. If I have, let's say, int x equals 3, y equals 2, and I have z as well. If I say z equals x times y, well, z has the value 6, but x and y shouldn't be changed. X should still remain 3, and y should remain 2. So this is the same idea with polynomials. So that's the first basic part. Now let's go ahead and go into more the details of how to implement this function. So in this function, we have the this and RHS. I'm also going to put, we also have the this degree. Now, you don't have to use this arrow degree. I just want to put that there only because it makes it more distinguishable. So this way we can distinguish that RHS degree is going to be that right-hand side polynomial object's degree and a polynomial expression, and then the this is going to refer to the left-hand side expression. So this and RHS is a way to distinguish. Now, if you don't put this arrow, it'll still work, but you have to have RHS dot poly expr or RHS dot degree. You don't have to do it for this arrow, but I want to put it there just so it's easy to distinguish. Otherwise, I can imagine, you know, some students getting confused about this. So what we're going to have to do in this function, we're going to essentially create a temporary polynomial object. So I'm going to go ahead and just say, maybe I'll create one and call it, let's say, polynomial. I'll call it product. So I guess for right now, leave this up to you. What is the product? What is the degree of this going to be? I'll let you kind of figure that out. And also, what size do we have to set for this expression? So expr equals new int, and I'll just kind of leave this open for right now. So just kind of figure out really what we have to do here. So what's going to be this resulting product? What's going to be its degree? What's going to be its expression length? So just look at this example for right now. Multiply P1 times P2. I mean, let's go ahead and just sort of work this out for a second. Well, you know, how do we actually work this out? Well, we multiply coefficients together and we add their exponents together. And for example, as I'm working this out, let me go ahead and sort of give this to you. Let me just sort of FOIL this out quickly. If I had the following expression. I'll make this look a little nicer. Plus 3. So just from, you know, from math, I don't know when you did this, what year in high school or junior high you did this. But if you work this out, let's just sort of quickly work this. So I'm going to first take this to multiply these two together. And this is going to give me, well, negative 16x to the power 5. So that's a big clue. I mean, let's just focus on these numbers. That's your big hint right there. And of course, you can have a nested for loop that's going to multiply each term with each other. And you're going to have to store that into a specific index of this product. This is going to be your product polynomial at the very end. So you have to go ahead and store all those in there. And then you have to, after you do all that work, you just have to return product. So I'll let you kind of think about the details of this, but this is really the whole code. So you're going to have a nested for loop to multiply each term of P1 with P2. And then you have to figure out what the coefficient is. And also remember, it's a very simple approach. You multiply the terms, so we add their exponents, and then we know where to store this into the resulting polynomial of that product polynomial. So now let's go ahead and discuss the other members. But really at this point, if you understand this one, the rest are really not much more different. But let's go ahead and discuss the other ones. Just let's do a little overview of the other operators for this class. Okay, so the other operator star function right here, which takes a polynomial star integer, that one's a very simple one. So multiplying a polynomial with just a number, that number multiplies to each term of the polynomial. So just think back to your algebra or arithmetic days of how to do that. So for example, if I have the following, let's say if I do something like, let's say I take polynomial 1, I'll take P1. Let's say if I do something like result equals P1 times, let's say 3. Well, then P1 is going to be this expression right here. So we're just simply doing this. So I'll just put this here. We really are just doing 2x cubed plus 5x squared plus 2x plus 3. Multiplying it by 3. So then multiply 3 to this term, to this term, and this term. And it's not going to cause the polynomial's degree to be increased. But same idea, if you don't want to modify P1 in this function body, so you have to create a temporary object once again. You can possibly use the copy constructor to do that. You also can find a way to use the other operator star function. So in fact, you actually can call this function right here. You actually can call this function within the other operator star function body. Think about it. This is going to be your RHS object right here, RHS variable. You actually can create a temporary polynomial object out of this, and then essentially just call upon the other operator star function. But you also can, just write this function from scratch. All you have to do is just, take P1 and you just do a copy of P1 using the copy constructor possibly, and then just taking that RHS term or 3 and multiplying it to each term like so, and then of course return that temporary object back, and then of course result will catch the result of P1 times 3. Okay, now let's go ahead and talk about our remaining operators, which I'll spend not so much time going into these. These ones are relatively not too bad, but I will go over the friend functions as well, just to give us an idea as to what their purpose actually is in this program. Okay, so let's go ahead and cover the plus operator, which is going to be very similar to the minus operator as well. So I'm going to kind of, in a sense, go over both of them right here. At least I'm going to go over the binary minus operator. There is actually a unary minus operator as well, but I'll discuss that separately after I cover this plus, which sort of covers the minus operator as well. So we have this, we're adding two polynomials in this example. So let's look at the following example like this. So using our same example as before, so we have A and B, the same arrays that I defined earlier, which is going to result in P1 and P2 being these two fractions right there in the comments right there. That's going to be the result. And we have result equals P1 plus P2. So relatively not so hard to work this one out either. So let's go ahead and I'll just somewhat kind of talk about it here really quickly, and then I'm going to go over sort of how you want to code this, but again, not too bad. And then plus 8x squared minus 2x plus 6. So to add two polynomials, we have to, loop through these two. But we want to go through the same kind of, place value or the same terms. You have to add 3 with the 6. Then we have to add 2 with negative 2. Then we have to add 5 with this value. And of course, you have to add negative 2 with 0, because there is no x to the third in our second polynomial. So we have to essentially, once again, we have to create another object in this function body and set the degree appropriately. So again, you have, I'll sort of color code this again. So we have this object, this poly expr, and we have this arrow degree, and we also have this RHS poly expr, and we have RHS dot degree. So we have to again create an object of type polynomial. I'll call this maybe sum. And you have to set this sum's degree appropriately. Now, I guess what's going to be the degree of this product sum of P1 plus P2? Well, it's going to be, in this case, going to be x cubed. But is there a reason why x cubed was the degree? Well, maybe it's the degree of the larger polynomial. Maybe that's going to be a degree of that product polynomial. Not products. What am I saying? I meant some polynomial. Is that going to be the degree? Maybe the bigger of the two, of this degree and RHS dot degree. I don't know. It's you can of course just think about that, but anyway. And then we're going to have our loop that's going to add up every single term, every coefficient of the same terms of the this and RHS object, and of course at the end just return sum. That's about it. And of course, there's a plus operator where we have a polynomial plus integer. Again, if this makes sense to you, that function should be really sort of a cakewalk, really. So I'm not going to spend more time on that. And the minus operator is, about the same thing as the plus operator, except, we subtract this polynomial, subtract RHS. So in this case, you would have to, just subtract all of that. So again, I don't want to give away too much, but really that's about really as difficult as it gets. So this really covered that plus and minus operator. So next, I want to go ahead and talk about our sort of our last member operator, which is going to be the unary minus operator. All right, so this operator function is going to be a minus operator, but you notice that in the actual parameters list, which is right here, we see that there's nothing there. So this is going to imply unary operators. So it's going to be that negation operator, or it's going to sort of apply a negative. It's going to swap the sign of each coefficient of a polynomial. So consider the following like this expression. So again, we're referring to that same two polynomials because, well, they're good enough examples to cover. So suppose you have the following expression like this, p1 times minus p2. So this operator, this right here, is going to be what calls that unary minus operator. It's going to simply return a polynomial that has sort of the following gets returned. So it's going to really just return back to us negative 8x squared plus 2x minus 6. But again, you don't want to update p2. So p2 still has to be 8x squared minus 2x plus 6. This negative is going to simply just return a temporary object that's sort of the, I guess, negation, or the all of the coefficients are swapped from plus to minus or minus to plus, essentially. So how do you work this out? Well, in this case, p2 is calling this operator. So in this function body, if you look at this, we have this arrow poly expr, and we have this arrow degree. So, I mean, we again could be able to just do a deep copy of, I'll put like right here, I'm going to say polynomial object. I'm going to call this, I don't know, I guess, deep copy object. And of course, you call it whatever you want to call it. I mean, how do we deep copy P2 within P2's own function body? What can we pass into this constructor that will just do a clone of ourself? Well, the big hint is we have this. I mean, we can dereference this, couldn't we? Wouldn't that be an object? That's a self object? I don't know. Maybe. That could work. So then, of course, you have a loop that's going to just simply swap each sign of each coefficient of the deep copy object and then just simply return deep copy object. So that essentially covers all of the basic sort of operators. So hopefully this gives you some scope of the problem. I'm going to, of course, just now talk about the rest of the class, but just going to be a very generic sort of, how shall we say, a very generic explanation for the rest of the class. Let's get to that last part. Okay, so I'm going to go into actually more detail with this friend function in a second. I want to just sort of cover these friend functions you have right there. So these functions are designed to work where, for our member functions for a class, it only works if we have a polynomial, then a plus or minus or star, and then we have either a polynomial or integer. So if we have a case where we have an integer, then a plus, and then our polynomial, we want to call this friend function right here. If we have, let's say, integer, then we have a star, and then a polynomial, we call this function right here, and then of course likewise for this one. If we have an integer, then a minus, then a polynomial. So the orders are a little bit off, but for the most part, we kind of can reuse our polynomial member function operators within these friend functions, because for the most part, the logic is somewhat the same. So I'll leave that to you to figure out. But I want to now go into this this friend function, the OStream operator function. This one's going to be rather not really so simple. It's not too bad, but it's going to be a little bit of logic you have to worry about. Let's go ahead and go back to OneNote and talk about the details of how to implement this function right here. All right, so here's our output stream function, or output stream operator function, sorry. And this function is going to work where we would do a cout, then we have this operator, and then we output a polynomial. So think of the following scenario like this. We want to output our polynomial kind of in a normal, natural way that we output variables in C++. So we have our cout, this operator, and then result. So what happens is this cout is going to be assigned over here, and then result is going to be just assigned to p. So we want to go ahead and output this polynomial p to the screen using output. Now we use oStream variable because, well, this is going to work whether we have a cout or if we were to use maybe some output stream variable. It works for either one. So that's why we use oStream to make this happen. So in this function body, well, we'd have to use output. So if you were to go ahead and just say output like this, it's going to, let's say if I say output p.expr, you know, let's say 1, and then x, then outputs sort of outputs the index 1 term. So we of course are going to just simply output each term one by one. So of course this is really out of order over here, but I'm just giving you an idea of how to think about this. We could say p.expr 2, and then x up to the power, I guess I'll just say 2 for right now. But of course, we're going to have a loop, and these are kind of going to correlate with each other. So of course, you have to have a loop that's going to multiply our output. Essentially, it has to start really from that leftmost degree and work its way all the way to that 0th, or that 0th term in that polynomial, of course. So this is going to simply output. So output will be your cout, and then p is going to be result in this case. So you have to write a loop that starts from that degree position and work its way down to 0 and output each expression one by one, but also want to output them in a nicer kind of form. So for example, let's say if you have result, I think the result is going to be, let me just sort of add these up really quickly. Result is going to be, we have that result in this result polynomial. So we want to output to the screen. We really want to output, essentially, this has to output negative 2x cubed plus 13x, or actually it's going to be written like this, that caret key plus 13x caret key 2 plus 9. So this term is a 0. We don't want to output 0x. And also, let's say, for example, what if, just what if, so I'm just going to modify, what if you actually had negative 13x squared? Then we don't want the output to actually say plus negative 13x. So you want to output this as just negative 13x squared. So you can refer to the outputs. I'm going to provide you with the output files with this write-up. And of course, CodeGrader will test all of these out as well. You want to make sure outputs these in a natural form, in a very nice, looking form of our polynomials. That's going to be the result of this output sort of function. So you start from the that highest degree term and work your way to 0. And of course, make sure you output pluses and minuses accordingly. So you don't want to have, I just say, you don't want to have a plus minus. That doesn't look very good. And also, we don't want to output x to the power 1, because that doesn't look good either. So you want to, x to the power 0, my mistake. We don't want to do this, so you want to just say just plus 9. And of course, if you have a 0 in the middle, don't output 0x, because that also doesn't look good. So that's what you really want to do for this function. After you do all that in a loop of some sort, then at the end, you're going to just simply return the output stream variable. So this way it can apply cout on this slash n right here. So the hope of returning the output stream variable is so it can apply the cout onto each individual component of the output statement. All right, so for the output portion, for the auto testing portion on code grade, there's no input for this program. It's going to be just a several set of main.cpps. So here they actually are. So I simply just create several mains that would just sort of test each function out. This one's going to test out the multiplication operator. So test out the addition. This does maybe just a little extra work, so it does like addition multiplication as well, and also will negate the result or sort of change the sign of that polynomial. So the fourth one does subtraction. The fifth one, it just does some of those polynomial integer operations. This one's a friend function. So basically that's all this one actually does. And of course the final boss is that one really big mega file. So I could have had just this one main only, but then the problem would have been that, okay, if let's say one of these doesn't work, then you get the entire auto test wrong. So I wanted to have these smaller tests right here to have you, so that way you can at least get partial points if some operators do work and some do not work. So I actually gave you a make file that's going to actually compile all of these. So it's going to simply link your polynomial.cpp file. So as long as you have, all you have to submit to CodeGrade is polynomial.cpp, and this is going to compile your polynomial.cpp file to all of these mains. So let's go ahead and sort of run the make file. So I'm going to just type in make as always, and it's going to just compile all of these. And there we are, we have several mains. So let's go ahead and just go to the file here. So I have it creates M0, M2, M3, M4, M5, M6, and also it creates, I believe it should be a final boss exe file somewhere. I guess I'm sort of not seeing it here in my Windows Explorer. So anyway, they're all supposed to be there actually. I just don't see where. I think it's probably this one right there. So anyway, so to run them, you just go ahead and just /m01, and it runs that first executable file. And then /m02 runs the second one, and of course, final boss, it runs that final boss file. So there we are. Now, of course, I'm going to just simply do a make clean right now just to clear everything out. So let's say, for example, you don't want to compile everything. You want to just test out one of them. What you could do actually is, let me just go back to the file explorer. So you can see here, there actually is no, I think these main files right there actually are from earlier. So I'm going to get rid of these right now actually. So there we are, let's get rid of these. So pretty much if I want to test out maybe just main03.cpp, I want to just only have this one compile, you can type in the word make and then main03, and it will only compile and link just main03. So that way now if you go back over here, we only have the main03, or M03 is going to be the executable file. So of course you can just go ahead and run that. So if you want to compile all of them, you can of course just compile, you can just sort of compile one of them by typing in make, and then which ones you want to do. Final boss, make final boss. If you type in make, however, just like that, it will compile all of them. So on the code grade, it's going to actually run make to compile all of them. And the auto testing is going to simply run each of your exe files and test each one of them out like that. So that way, if let's say the final boss doesn't run, but the other smaller ones do, then at least you get some partial points is the idea. So anyway, that's the end of this video. I hope this did help you get an idea of how this assignment has to be done. So I guess happy coding, take care as always, and until next time.